Hello and welcome. Think about the last app you used. Did it check if you were old enough to sign up? Or maybe if an item was in stock? Well, those simple little decisions are really the lifeblood of software. Today, we're going to pull back the curtain to see exactly how it's all done in Java. We're diving into relational operators. These are the fundamental tools that let our programs compare, reason, and make smart choices. And honestly, mastering these is the very first step to writing truly intelligent code.
So here's our game plan. First, we'll talk about the why. Why comparing stuff is so important. Then, we'll meet the 6 key operators you need to know. After that, we'll get into the one golden rule that controls all of them. We're also going to tackle a super common beginner mistake, which will save you a lot of headaches later on. And of course, we'll see it all work with some real Java code before we wrap up with a quick recap. All right, let's get into it.
Okay, so first things first. Why does any of this even matter? Well, it's pretty simple. Just like us, programs need a way to look at their data and make a judgment call.
I mean, think about it. When you sign up for a social media account, that app has to check your age, right? It's literally asking the question, is this user's age greater than or equal to 13? Or when you're shopping online, the website is checking, is the number of items in stock greater than 0? This isn't magic. It's just the code asking very precise questions, and it uses relational operators to do it.
And that's really the core idea here. Every single intelligent thing a program does, whether it's logging you in or guiding a self-driving car, it all boils down to comparing one value against another. Relational operators are the language it uses to make those comparisons.
So how do we actually do these comparisons in our code? Well, Java gives us a specific toolkit for the job. Let's meet the 6 essential relational operators you're going to be using all the time.
Here they are. The first 4 probably look pretty familiar from math class, right? We've got less than, greater than, less than or equal to, and greater than or equal to. Now, the last 2 are super important and a bit more specific to programming. To check if 2 things are exactly the same, we use a double equal sign. Not 1, but 2. This is so crucial. And to check if they're not the same, we use an exclamation mark followed by an equal sign. Just think of the exclamation mark as meaning not in the programming world.
Okay, so now we know what kinds of questions we can ask, like, is x greater than y? But what kind of answer do we get back? Well, it turns out it's actually way simpler than you might think.
The answer to any comparison is always a special data type called a Boolean. The best way to think of a Boolean is like a light switch. It can only be on or off. That's it. A Boolean value can only ever be true or false. There's no in-between, no maybe. It's the computer's way of giving a definite yes or no answer. And this right here is the golden rule. It doesn't matter how complicated the numbers are. You could be comparing huge decimals or tiny integers. When you use a relational operator, the final result is always, and I mean always, a simple true or false. So, is 5 less than 6? True. Is 100 equal to 99? False. Simple as that.
All right, listen up, because this next part is so important. This is probably the #1 bug that trips up people when they're starting to code. It's all about the equal sign. So a single equal sign, that's the assignment operator. It's a command. It means, hey, take the value on the right and stick it into the variable on the left. But the double equal sign, that's the equality operator. It's a question. It asks, hey, are the values on both sides of me the same? So one gives orders, the other asks questions. They're completely different.
This is a rule you just can't break in Java. If you mix them up, your program is not going to work the way you think it will. To ask a question, does x equal 5, you absolutely must use the double equals. If you accidentally just use 1, you're not asking a question anymore. You're giving a command. Make x equal to 5. Seriously, this causes so many problems for new programmers, so please burn this distinction into your memory.
Okay, enough talk. Theory is great, but the best way to really get this is to see it in action. Let's walk through a super simple Java program and just watch how these operators behave.
And the process is really straightforward. We're just going to create a couple of number variables, compare them, catch that true or false answer in a Boolean variable, and then print it out so we can actually see the result.
All right, let's look at the actual code. First, we need something to work with. So we'll declare 2 integer variables, x and y. Let's say x is 6 and y is 5. We also need a spot to put the answer to our comparison, right? So for that, we'll declare a Boolean variable and call it result. Right now it's empty, but it's ready and waiting to hold either true or false.
Okay, time for our first comparison. We'll ask the question, is x greater than y?
So in the code, that looks like result equals x greater than y. What Java does is it looks at the right side first. It sees x greater than y, which is 6 greater than 5. Is that true? Yes, it is. So that whole expression becomes true. And then that true value gets assigned to our result variable. So if we printed result right now, we'd see true on the screen.
Let's try another one. This time, let's ask, is x less than or equal to y? Well, is 6 less than or equal to 5? No, of course not. That's false. So, the expression x less than or equal to y evaluates to false, and that's the value that gets stored in our result variable this time around.
Now let's check for equality. First, let's change things up a bit and set y to 6. So now x is 6 and y is 6. They're the same. Then we use our double equals operator to ask, is x equal to y? Since they both hold the value 6, the expression x equals y evaluates to true.
And finally, let's try the not equal to operator. Remember, x and y are both still 6. So if we ask the question, is x not equal to y? Well, that's a false statement because they are equal. So the expression x not equal to y evaluates to false. Whew, okay, we've covered a lot of ground, from the big idea of comparison all the way down to the nitty-gritty of the code. Let's just take a second to recap the most important points. So let's lock this in. First, relational operators are just for asking questions about two values. Second, the answer you get back is always a Boolean, true or false. And third, the one rule you have to remember, use a double equals to compare and a single equals to assign a value. Getting that right from the start is going to save you so many headaches, I promise.
You know, it might seem like a small thing, but you've just learned one of the most powerful concepts in all of programming. Every complex piece of software you've ever used, from video games to AI, is built on a foundation of these simple little comparisons. You now have the basic building blocks to make your programs think.
But of course, this brings up a new question. What happens when one comparison isn't enough? What if you need to check if a user is over 18 times and they live in a specific country? How do you combine those true or false answers? Well, that's exactly where our next topic, logical operators, comes into play.